Okay, this video is for my Calculus 1, and it's our extreme values of graphing using our first and second derivatives. So this is problem number 5, and I kind of started setting these up because before I do the video, because I kind of do the same thing. The first thing I want you to do is sketch the graph. I'm going to show you I did graph it on the graphing calculator. Set up your F prime and F double prime bars, which are number lines to talk about your derivatives. And then I'm going to stack and rack the critical points, inflection points, y-intercept, horizontal, and vertical asymptote. As you can see by the y-intercept, I put 0 a number, and that's easy to do because all you can do is plug in 0 in your graph, and after your graph, you can look at the table. When I plug a 0 in both of those spots, I get a 0. So it crosses right at the origin, and all you have to really do is look at your table. Because this is a polynomial, it's not a rational function. There is no horizontal asymptote to find, and there's no vertical asymptote to find. So you don't always have to have that, but we're going to make sure we check for it. So now we're going to go through and do this. So first, we're going to do critical points and inflection points, but I want to show you that I did graph this. So here's my graph. And a lot of times everybody goes, well, how do you make it fit? See how I went up to 10 and negative 25? And the reason why I did that is because I've already done the algebra before to know how to fit it in the window, okay? And so there's what the graph looks like, and we're just going to do all the calculus to justify. So first thing we're going to do, and this is nice because it's all the power rule, is we're going to find the first derivative. So f prime of x is going to be 3/4 x squared minus 4x. And I'm going to put it equal to 0 so we can find where the slope is 0 or our turning points. Now what we're going to do is factor. So I'm going to factor out an x because I can. So I have 3/4 x minus 4. You could actually factor out more, but I just did that to begin with. So I now know x is going to be 0 as one of my points. So it's going to be 0. And we already showed it was 0, 0. So it's the y-intercept, the x-intercept, and now it's a critical point as well. And then I have 3/4 of an x minus 4 equals 0. 3/4 of an x equals 4. X is going to be 16/3. Okay, so I know the point is going to be 16/3 something, and when I plug in 16/3, I get a negative 18.963. So this is kind of where I get where my lows and highs are. So let's kind of set this up here. I'm going to use a different color here. Let's use blue. So here I have 0, and then I have 16/3, which is a little over 5, if you will. So here's our 16/3. I kind of set it up. There are critical points, so I'm just going to put them here. So 0, 0 is a critical point. 16/3, negative 18.963 are my critical points. Now I got to check my local mins and local maxes. And like I told you in class, you can actually graph your first derivative and just look at the values. So I'm just going to kind of go through here in this area right here and plug in some points to the left of 0. When I go to the left of 0 for negative numbers, this is negative. And a left of 0, say I will say negative 4, this is going to be negative, and negative times a negative is going to be positive. So let's use this color. Between 0 and 16/3, let's pick 1. If I put a 1 in here, this would be positive. I put a 1 in here, it'd be negative. So it's going to be negative in here. And over 16/3, let's try, I don't know, let's try 8. If I put an 8 here, it's positive. This is going to be positive, so this is positive. So this means it is increasing. My function's increasing, decreasing, increasing. And then I look at it and say, oh, I've got to do the first derivative test. Don't forget to do that. So I'm going to do the first derivative test right here. So if it's increasing, then decreasing, this is a max, a local max, okay? If it's decreasing, then increasing, this is a local min right here. So I'm going to come down and put it here. So at 0, 0 is my local max after I did my first derivative test. And this is going to be my local min. So that's good. Now we're going to do our inflection points. So here we go. We have to do F double prime for inflection. So I'm going to use this this right here for our inflection points. Okay. So F double prime of X is going to be 3/2 X minus 4 equals 0. 3/2 X equals 4. X comes out to be 8/3. So it's 8/3 something. And when I plug it back into my original, I get negative 9.48148. So I don't have inflection points. I just have an inflection point where it's changing in my concavity. So there's my inflection point. Now I'm going to come back up here. 8/3 is going to be in here somewhere. And remember, it's a sketch, so it's going to be in here somewhere where the change in the concavity happens. So you can put your second derivative in the graph, which would be this right here. And you could go to the left of 8/3 and to the right of 8/3. So if I go to the left of 8/3, that's like a 0. That would be negative. If I go to the right of 8/3, you could pick 10. That'd be positive. So this is concave down to here, and this is concave up. And that's what my sketch looks like. So you can always stop these videos, do them yourself, and see if you're showing all that work you need to. So I hope that helped. I'm going to keep doing more.